Now we discuss a very important game called the Pirate game. This you can find in Wikipedia. This game has a lot of applications. So we will do this via an example. So suppose there are 5 rational pirates, A, B, C, D and E. These pirates believe in democracy, but to run the ship they have a order of seniority. Just like in any corporation you have an order of seniority. So A is, say, the CEO of the ship. So A is at a higher rank than B, B is higher than C, C is higher than D, and D is higher than E. So every time they find a treasure, the senior most pirate, he decides how much gold coins he will keep and how many gold coins should be given to each of the other pirates, B, C, D and E. So A is really greedy pirate. All of the pirates are greedy, and A wants to maximize the number of gold coins he wants to keep. Now once he comes with the proposal, so he puts the proposal in front of the crew. So that all the pirates now listen to the proposal. So the pirates listen to the proposal of the senior most pirate, in this case it is A, and then vote in the favor of the proposal or against the proposal. So if the votes, there are more votes in the favor of the proposal, so either if there is a tie or there are more votes in the favor of the proposal, then the proposal is accepted. Now if the proposal is rejected, in that case there is mutiny on the board. So say C, D and E vote against the proposal, there will be mutiny on the board. Then the leader A, he is thrown into the ocean because he was the one who came up with the proposal. So he is thrown into the ocean. So leader A dies. So now the game again begins with leader B. So now B will decide how the treasure should be split. So suppose they find 100 gold coins. So what is the optimal distribution of gold coins? So how many gold coins should A keep? How many he should give to B? How many he should give to C? How many he should give to D? And how many he should give to E? So the trick to understand the solution of this game is backward induction. So what does backward induction mean? So suppose you are standing in a maze. So this maze has 2 paths going. One goes to the left, the other path goes to the right. And at the end of the right path there is gold. So we are standing at time equals to 0. So to get to gold at time equals to 1, the person will take obviously the right path. So he wants the gold. So he takes the right path and he gets the gold. So now let us do in 2 steps. So say now again there is a maze. You have left and right, and that end of right tunnel there are 2 more tunnels, left and right, and the gold is lying here. So this is present, time 0, time 1, and this is time 2. So you tell the person that this is the layout of the tunnels and the gold is right here. So the logical way of thinking is that the person starts at this point and he says, if I'm already in the future at this corner, then I will take right and I will reach the gold. Then he inducts backward to present and say, to reach this node, to reach this decision node, he has to take a right. Only then he will reach this decision node and then he can go the gold. So he takes a path right at time 0 and takes another path right at time 1. So at time 2 he reaches the gold. So this is the logical way of thinking. Now this might seem a bit far-fetched if you are just thinking like that, but if you can talk to a professional bodybuilder, so the professional bodybuilder will tell you that when they try to build their body, they just don't go to the gym and start doing weights. So they say that building a body is like building some beautiful architecture building. So they have like a 10-year plan. So the first, you need to have in mind what kind of physique you want to build in 10 years. According to that, then you induct. So what should be your physique in year 9? What should be in year 8? And then all the way to present time, so that you can build slowly and follow the path so that you can get there. So this is a logical way of thinking, and this is precisely what we are going to use. So we are going to start at this decision node, that is at future -1, and then go backwards to come to the present. We now use backward induction to solve this game of distributing 100 gold coins optimally. So now assume A, B, C are dead and we are standing somewhere distant in the future where only D and E are alive. So D is in charge. So now D proposes that he gives himself 100 coins and 0 to E. So now they are going to vote against or in favor of the proposal. So in favor of the proposal, D will vote, and against it, E will vote because he got nothing. But there is a tie here now. There's 1 vote in favor, 1 against, and we have this greater or equal to sign here. So there's an equality here. There's a tie. So this is acceptable. So D gets to keep all the 100 coins and E gets 0 coins because against vote doesn't count. There is 1:1 vote. There's a tie. So E does not want to be in this situation where he gets 0 coins. So he does not want to be in the future where only D is in charge. Now we go one step backward. Now C is in charge. C is the king. Now what will C do? Now C will give himself 99 coins, give 0 to D and 1 to E. So now again they will vote. So C will obviously vote in favor, and E will also vote with C because E knows that if he votes against C, then D and E will throw C overboard, but then D will give him 0 coins here. So C said 1 coin is better than 0 coin, so let me vote with C, and D is going to vote against because he doesn't get any coins. But now you have 2 votes in favor and 1 against, so this distribution is optimal. Now we go 1 back again in the future. Now B is the king, or B is the leader or CEO of the ship. So what will B do? So B proposes he keeps 99, gives 0 to C, 1 to D and 0 to E. So B will obviously vote in his favor, but along with B, D will vote, because D knows that if he votes against B and they kill B, he will be in this situation where he will get 0 number of coins, and he does not want 0 coins, he wants at least 1. So B and D, they both vote in favor, and C and E obviously will vote against because they are not getting anything. But then you have a tie here, so this proposal is also optimal. Now coming back all the way to A. So what should A do? A is the leader. So A gives himself 98 coins, gives 0 to B, 1 to C, 0 to D and 1 to E. Now A will obviously vote in his own favor, but then C will vote with him and E will vote with him, and B and D, because they got 0, they are going to vote against the proposal. Now C and E, they vote in favor of A because they know if A is dead, they will be in this position here, C and E, where they will get 0 coins. So getting 1 coin is better than getting no coins at all, so they will vote in favor of A. So you see, the optimal distribution of gold coins is that A gets 98 coins, B gets 0, C gets 1 coin, D gets 0 and E gets 1 coin. So this is the optimal distribution of coins. Now this game might seem imaginary, but this is highly applicable to the societies we live in. So let us see some applications of this. So the first homework is to make sense of this quote. I can hire one half of the working class to kill the other half. So this was said by Jason Gold, and he was an American financier and railroad developer. So you need to try to make sense of this quote with this argument right here. So you see that C and E can keep B and D in check, whereas A can make all the money. So A could be Jason Gold, and he can give just 1 gold coin to C and E to keep B and D in check. So this is number 1. So number 2, again food for thought, is why are CEOs paid so much more? I mean, after all, they do not produce that much, or by themselves they're not producing that much. That is because they are at the head of the chain. just like A is at the head of the chain, so he can decide to give himself whatever he wants to, and give very little to C and E so that B and D are in check. Number 3 is that another homework is that you need to read about the history of workers' union. So when I was studying in London School of Economics, there was exhibition on the history of workers' union, and that taught me a lot of things. So the first thing was that the workers in England, where Industrial Revolution happened, they used to work from sunrise to sundown. And in the summers, the sun rises really early. It is the sun starts shining at 4:30 a.m. and it sets late in the night, about 9:30. So the people were expected to work from sunrise to sundown, and the first demand for the workers' union was they just wanted hours from 7 a.m. to 7 p.m. And the owners, they said that this should not be given to the workers, because if they get off the work early, they will just go home and gamble and cause rioting in the streets. So this should be denied. Again, it was the workers' union who brought about the weekends. Earlier, there were no weekends. People just had to work all the time. And another thing workers' union brought about was abolishment of child labor. So child labor was very popular in coal mines in England because the children were small, so they could tie coal buckets to their leg and pull themselves out through small holes. So again, you can see that how exploitation can take place in such a scenario, which is actually democratic in the sense that people have the right to vote, but there is just an order of seniority.